Hi, my name is Karina Patel, and this is Physics Lab 3, Black Hole in Orbit. So in this lab, in part 1, we found the mass of the black hole, and then in part 2, we used that calculated mass of the black hole to determine the initial velocity of the spaceship. And in both of these parts, only GlowScript was used to perform the experiment, and the fundamental physics principle that this lab uses is Newton's second law, which will be explained later why. So for the preview of the results, the mass of the black hole was 1.6732 e to the 34, and then we had to use assumptions and play around to find these numbers, but this is what I got for the ship's velocity. So the concepts used on the left this is a concept that we used for the first part of the lab, where F net is equal to F parallel and F perpendicular. And that was used to find the mass of the black hole. And then on the right, that was used for part 2, where the universal gravitational force for an object in space is equal to the gravitational constant times the mass of object 1 times the mass of object 2 over the distance between the two objects squared. So the code for part 1 is screenshotted on the left, and at the bottom around 192 and 193 is when the mass of the black hole was calculated using the calculations that were conducted above that. And then in this experiment, the system is a star and the surroundings are the black hole. And then for part 2 on the left is my code, and this is how the Newton's second law is incorporated, because we use position update and velocity update, which are derived from Newton's second law. And then on the right, you can see the projection that occurred when I ran the experiment, and you can see the ship in purple breaking free from the gravitational force of the black hole. So possible errors that occurred: this is just a simulation in GlowScript, and in reality, there may be other forces acting on the star which would alter its velocity, because we do not take in every possible force and every single possible object in reality of space. And then trial and error were used to find the velocities, so I could have been more precise by trying more values for velocity. So what does it mean? Discuss how the net force and its parallel and perpendicular components are different from the rate of change of momentum and its parallel and perpendicular components. And we know that these are actually the exact same things. However, for net force, you must know each individual factor exerting a force in the system. For dp dt, you just need to know that what the system's change of velocity is. So it is a little bit simpler to use dp over dt, especially if you use F net parallel and F net perpendicular. There are different equations that you can use to set, even if you don't know what exactly dp dt parallel or perpendicular is, there's some concepts and equations that you can use to simplify it for yourself, like mb over r. What if this imaginary system has a black hole, a star, a planet, and a moon? If you wanted to predict the motion of the entire system, what would you need to include in your computational model? Think about all the interactions in the system. Would there be any dominant interactions, or would they all contribute more or less equally? So we know that they will not all contribute equally, because FG is constantly changing, and depending on the size of the object or the distance between those two objects. So I'll explain below, but they will not be equal. So gravity would act between every object in the system, leading to me having to calculate many more forces rather than just the force between the black hole and the star. And then since the black hole and the star have the largest masses, the interaction between them two would probably be the most dominant, because the larger the mass that's in the numerator of the equation, it'll increase the gravitational force. And then the planet and moon interaction could also be very strong because they're very close to another. Because r is in the denominator and it's squared, so that means it will have a large contribution on the effect, on the outcome of the equation. So in conclusion, thank you for watching. I hope you learned something.